All right, so this is the last part to the algebra and trig review. So it's part 6, and this problem, probably 2 problems, are focused on logarithms and exponential functions. Really just logarithm rules and exponential rules. This first problem says expand using logarithm rules. And I wrote down the rules right here. So if you have a logarithm plus another logarithm, you can combine that into one logarithm where you multiply a times b. Subtraction turns into division. And if you have the logarithm of something raised to the x power, you bring the exponent in front of the logarithm. And this number 4 is really crucial. This is the inverse relationship between ln and e, is that if you apply each function with the other one, you get back the input x. So these are crucial. They rely on inverse functions. So if I have some function f of x, its inverse is, and they write it as f, and it looks like a -1, but it's not f to the -1 power. It's just a notation for the inverse. And the relationship is, if you apply the function f with this inverse, you get back the input x. And then go in the reverse order, applying the inverse with the function. It also gives you back x. So ln and e are just type of functions that are inverse functions. There's more inverse functions. And so like f of x is the function e to the x, and its inverse is the natural log of x. Just a specific type of inverse functions. All right, so let me do this problem now. So expand using the logarithm rules. So I'm going to say solution. Well, because there's a division, I'm going to first change this so into 2 logarithms, where I'm going to be using this relationship. So by 2, we can write it's x to the 7 square root of pq to the 3rd divided by e to the 5th. So I can write this as the natural log of the top part, x to the 7, and then the square root pq to the 3rd. All right, so that's the top part, then minus the bottom part. All right, so then from here, because there's technically a multiplication when I have x to the 7th, they just don't write the times, it's just implied. So since there's this multiplication, I'm going to apply rule 1. And that's changing a multiplication, so natural log of AB into addition of 2 natural logs. All right, so that's going to be equal to, and I'll put it as a natural log x to the 7 plus the natural log of this square root of p times q to the third. And the natural log of e to the fifth, well, because of the inverse relationship, so because of this one, you could write natural log e to the fifth, like your 5 is considered to be x in this case. It just becomes 5. So this would be minus 5. So I used the inverse relationship. All right, that's where the 5 comes from. I just ignore, it's like you can cancel out, like essentially since they're inverses, the natural log and the e cancel each other out, so you're left with just the exponent. All right, so now what I'm going to do here is x to the 7. So I have an exponent, and you can write the exponent in front of the natural log. So it'll be 7 times natural log of x. And that is using rule number 3, using this one. All right, so this is by rule 3. Then plus, and you'd have to remember from algebra class that if you have a square root, that's the same thing as writing this to the 1/2 power. And since it's a 1/2, I can bring the 1/2 in front of the natural log. And again, that's using rule 3. All right, now we've got to be careful right here. So I do have a product. I have n times q to the third. And so how I'm going to expand this, because I have this 1/2, I'm going to put 1/2, and then I'll use brackets just so it don't have too many parentheses, and I'll expand this. So it's the natural log of p plus natural log of q to the third. And I still have minus 5. And so that plus comes from when I have multiplication of a single logarithm. I'm using rule 1. Now I'll keep going. So I have 7 times natural log of x plus 1/2, and then times natural log of p. And because the q has an exponent of 3, I'm going to bring the 3 in front of the natural log. So it'll be plus 3 times the natural log of q. And then all of that's in brackets because that 1/2 is applied to that whole thing. And then minus 5. All right, so that, I believe that was rule 3 that I had listed. Yeah, so rule 3 dealt with the exponent. Okay, so I just brought the 3 in front. So this is by rule 3. All right, so I'm pretty much there. All I'm going to do now is distribute 1/2. So it'll be 7 times natural log of x plus 1/2 times natural log of p. And then do 1/2 times 3. That'd be 3/2. Natural log of q. And then I still have the minus 5 at the end. All right, and that's going to be the expansion. That's the farthest I can go. And I would accept the one above, so I would accept this also. All right, so I listed each rule. Obviously, when you're doing the problem, you don't have to justify every single detail like this. I'm gonna do the problem over again, but just quicker without writing by rule 2, by 3, and so forth. So here's how I would do the problem. That's just to go over all the steps. So here's a quicker version of the same thing. So I can do like multiple steps in one. So again, first thing I did was I separated this into two logarithms because of the division sign. It changes it to a subtraction. No, I'm sorry, I'm getting ahead of myself here. All right, then because there's technically a multiplication, because I have x to the 7 times the square root of p q to the third, so I changed that to addition. So I separated it, so natural log of x to the 7 plus the natural log of the square root of p q to the third. And then I use the inverse law, inverse relationship, natural log and e cancel out, so you just get the exponent 5. So it's like these cancel each other. Then I brought the 7 in front of the x using that exponent rule. So it'd be 7 times the natural log of x. And then I recalled that square root is the same thing as raising something to the 1/2 power, which means I can bring the 1/2 in front of the logarithm. And so inside this, I have a product. So I expanded it. So I had it as the natural log of p plus the natural log of q to the third minus 5. So I had that exponent 3 that I brought down to 3 times natural log of q. All right, and from there, so I would accept this. So that was possible answer, right? And then you could multiply 1/2 through if you want. Let's say, or 7 times natural log of x plus 1/2 natural log of p plus 3/2 natural log of q minus 5. All right, so that's how I would do it. Just I'm not writing by rule 2, by rule 3, or whatever. It's at this stage we're supposed to have already have these rules, like know these rules, since that was from algebra. I'm gonna do one more, and so that it's gonna be a little bit different than this one. So this next one's gonna be number 13. And it's gonna be simplify, and it's e raised to 2 times natural log of square root of 9, and then plus 2 times natural log of x. So that whole thing is the exponent. So some exponent rules I'm going to apply. So if I have e to the a times e to the b, that's e to the a plus b. That's one of the rules I'm going to apply. I'm going to apply of the natural log of a to the b. That's b times natural log of a. And then I'm going to apply the inverse property or inverse relationship. All right, these are some rules I'm going to apply to this problem. So here, the first thing I'm going to do is, so I'm going to write, so this will be solution. I'll break it up because it's an exponent, the whole thing. So I would first use the first rule so that it turns into e 2 times natural log. I guess you can go ahead and write square root of 9 is 3. And then plus, or sorry, e raised to 2 times natural log of x. So I just used rule 1. All right, what else can I do? So I'm going to bring this 2 up to where it be e to the natural log of 3 squared. That's just using the second rule. And then times e to the natural log of x squared. And that's just using rule 2 on the left. Well, what is 3 squared? That's 9. So this is e to the natural log of 9. And then e to the natural log of x squared. Well, I can use this inverse relationship. And the e and ln cancel out to where you just get the x squared. So it'd be times x squared by the inverse relationship. All right, same thing for this, where I have e to the natural log of 9. The e and the ln cancel, so I could write that as just 9, and then x squared. So I'd use the inverse relationship again. All right, and that's it. That's going to be my answer, 9x squared. All right, so this is equal to 9x squared when I simplified it. And this concludes the algebra and trig review. Now, this ended up being longer than I was anticipating, but I figured I'd go through a bunch of examples as a review. And the next video is going to be actually starting out with chapter 1.